Hello, welcome back to class. That's Internet of Things class, and we'll be looking at artificial intelligence and robotics in Internet of Things, artificial intelligence and robotics in Internet of Things. We'll look expandedly um, in the module on this content, but this will be a brief video to introduce us to the course, and we'll be looking at the relationship between uh, Internet of Things and artificial intelligence. We look at machine learning in Internet of Things system. Look at intelligence, automation, and smart system. We look at robotics and autonomous Internet of Things devices. We also look at predictive maintenance and control. And lastly, we'll look at the ethical considerations in AI-enabled um, Internet of Things. We will be able to delve into the synergistic integration of artificial intelligence and robotics with the Internet of Things. And while the Internet of Things establishes the foundation and or connectivity and data collection through sensors and networks, AI introduces the cognitive capacity into it, which enables system to be able to analyze, learn, and also make decision autonomously. And the robotic extend this capability further uh, into the physical world by ensuring the performing tasks are performed with precision and adaptability. And this actually would be able to help you to be able to explore how AI and robotics transforms Internet of um, Internet of Things from a network passive data collector into an intelligent, proactive, and autonomous ecosystem capable of optimizing operations, predicting outcome, and also enhancing human experiences across diverse domain. Looking at the relationship between Internet of Things and AI, as per the data provider, Internet of Things devices such as sensors, camera, actuators generate vast stream of real-time data from physical environments like temperature, motion, vibration, usage pattern, and more. And the AI is seen as the intelligent interpreter. So if we say that the Internet of Things is actually the data provider, we see the artificial intelligence as the intelligent interpreter, and the AI algorithm process this data into to be able to identify patterns, detect anomalies, predict trends, and also make informed decisions. And techniques such as the machine learning, computer vision, and natural language processing are employed in doing this. And we have the convergence creates intelligent system such as the real-time decision making, where AI analyzes incoming data to trigger immediate responses, and also the predictive capability, dealing with forecasting future events, and lastly, the adaptive learning. It deals with system improve over time by learning from historical data and the new input. For the machine learning, this is actually the engine of intelligence in Internet of Things, and it is a subset of artificial intelligence that enables systems to be able to learn from data, identify patterns, and also make decisions without explicit programming. And the key types of machine learning in Internet of Things include supervised learning, which uses labeled database or data sets to be able to train model for tasks like classification, regression, and regression. Or also, we have the unsupervised learning, and this identifies hidden patterns in unlabeled data through clustering and association. And we also have the reinforcement um, learning, and for this, system learns through trial and error by receiving reward for desirable actions. And we have the ML, the machine learning deployment architecture, as it's been seen, and this is a cloud-based ML. We have the edge-based ML, and we have the fog computing. Let's apply this to machine learning. Let's apply machine learning rather to Internet of Things system. And when we talk about it, we see it in the aspect of predictive maintenance. That is, machine learning model analyze sensor data to predict equipment failure before they occur. And this reduces unplanned downtime and maintains cost. Also, as per smart healthcare, it's applied to smart healthcare, and the wearables, Internet of Things devices collect patients' vitals. The algorithm also detects early signs of health issues and also alert caregivers. In the smart transport, the machine learning optimizes traffic between um, traffic flow, rather by analyzing data from camera and sensors, reducing congestion and improving the safety. And we also have the industrial Internet of Things, and this enhances quality control by identifying defects in real time and optimizing production processes through adaptive automation. And lastly, we have the energy management. And for this, it forecasts energy demand and adjusts distributions in smart grid, improving efficiency and sustainability. We have the challenges in implementing machine learning for Internet of Things. The first is resource implementation. There is also the data quality and volume constraints also. There is also the security and privacy risk, and that this talks about transmitting sensitive data to the cloud for analysis, increases exposure to breaches, and it ensures that there is need to ensure data encryption, secure access control, and also compliance with regulations in such an instance. Another challenge is the model maintenance and adaptability, and the last one is the integration complexity, which is another constraint or challenge. And this talks about combining diverse Internet of Things devices, the communication protocol, and the machine learning frameworks into a cohesive system process, which is significant in terms of technical and operational challenge. Looking at the intelligent automation, and this is talking about creating smart and adaptive system, and this refers to system that integrate Internet of Things, AI, and also control mechanism to perform tasks autonomously, adapting to changing conditions, and also optimizing operations without human intervention. And we have core characteristics in terms of it's been data-driven decision making. In its data-driven decision making, that is, it uses real-time and historical data to be able to inform actions. Another is a continuous improvement in performance through experience. Also, it's the real-time responsiveness, that is, it instantly reacts to environmental changes. And lastly is that it connects disparate devices, platforms, and services into a unified ecosystem. And this can be applied to smart buildings, industrial automations, healthcare monitoring, and smart cities. For the robotic and autonomous Internet of Things devices, robotic in Internet of Things refers to mechanism or mechanical system employed or equipped with uh, sensor actuators, and AI capacity connected via Internet of Things network to perform tasks autonomously. And it has a key features in that it's known for autonomy, that is, device operates independently using embedded algorithm. Also, it communicates with other devices, cloud platform, and control center in real time. Another is that it adjusts actions based on sensors, input, and environmental changes. And lastly, it performs repetitive or complex tasks with high accuracy and consistency. And this is applied to industrial robotics, also healthcare robotics. We also have the autonomous vehicle, and lastly is the service robotics. This is actually applied to when we talk about Internet of Things. Looking at the predictive maintenance and control, it's actually an approach that uses the Internet of Things sensors and AI analytics to be able to monitor um, health to predict potential failure and also to schedule maintenance before breakdown occur. And how it works is that first is data collection, and the next is to transmit data, and also the data is being analyzed using um, machine learning model which detects anomalies, identify trends, and also predict failure probability. And lastly is the automated actions, and it is applied to manufacturing, transportation, energy sector, and also likes of healthcare. Lastly, the ethical considerations in AI-enabled Internet of Things system. Um, when we talk about this, it's the AI-enabled Internet of Things system collects sensitive data which make autonomous decisions and also operates in critical domains, raising significant ethical, legal, and social concern. And key ethical principles that are very important to see or note or put practice is the privacy and data protection. Another is transparency and explainability. Another is accountability and responsibility. Also, it is very important to practice bias and fairness, that is, use diverse representative database to be able to train AI model and present discriminatory outcome, and conduct regular bias audits and algorithmic fairness assessment. And lastly, is the societal and environmental impact, which is very, very important as we talk about the ethics in ethic consideration in AI-enabled Internet of Things system. In conclusion, the convergence of AI, robotics, and Internet of Things is not merely technological. It actually represents a shift towards intelligent, autonomous, and ethical grounded system that enhance human capabilities, improve quality of life, and drive sustainable innovation. Thanks for listening.